Hello students, myself Sihab Islam from CITM. I will take this subject of structural analysis from today onwards. Now, this subject is categorized as a different module. The first thing we have to know the subject under this subject, the indeterminacy. Okay. Indeterminacy. So normally indeterminacy is divided into two parts. Number one is static indeterminacy and number two is kinematic indeterminacy, right? So first of all we have to know what is support condition, what is loading condition, what kinds of beams are there. Okay, so in structural strength of material subject in previous semester you all know about that. So first I would like to introduce what is external support reaction, right? So in this case we have three support normally, right? Fixed support, hinge support and roller support. First come fixed support. Right? Fixed support. It looks like this. This is the I have cut it from down. Okay. So in this case, in fixed support, if we add some load here, right? It's P load. I take this is P load and this is theta in angle theta. This is point A and this is point B. Clear? So as this load comes in inclined portion, it will create a vertical reaction force. I mention it as Ry, horizontal force Rx, and for this angle there will be a moment, right? The moment is mz. Okay, so here displacement at in x direction is 0 because this fixed support restrained it. Okay, del y is 0. As vertical direction also the displacement is restrained, and as well as in case of moment also. So we can write that restraining the displacement will lead to the formation of external support reaction, right? So here number of support reaction is we mention is as RE. That is reaction and E for external support, right? So number of external support is 3. That is Rx, Ry and Mz. Clear? Okay. So for similarly for hinge support this looks like this. Okay, so here RE value comes to, this is RX and RY, as hinge support can't take moment. Okay, and number 3 is roller support. It looks like this. Okay, and in this case roller support, number of support reaction is only 1, and this is only RY, as in this case RX not happening. Okay, you give any horizontal load, and this is a roller, so it can't withstand any horizontal loading, right? And in this hinge case, this is RY and this is RX. It can withstand vertical as well as horizontal forces, right? So we can summarize as support, this is fixed, hinge, roller. Figure. This figure comes that way. This. Okay. And horizontal force, vertical, this is H, this is V, and this is moment. Okay, so in case of hinge, in case of fixed, it can take horizontal force, vertical force and moment. In case of hinge, horizontal, vertical, but no moment. And in case of roller, it can take vertical but no horizontal and no moment. Clear? Okay. Next thing is come in our chapter in this topic is internal forces. Internal forces. So in internal forces there are 4 part comes. Number 1 is axial force. Number 2 is shear force. Number 3, bending moment. And number 4 is twisting moment. Now, what is the difference between twisting moment and bending moment? Remember one thing, in case of bending moment, the moment is always in the transverse or lateral axis, and in case of twisting moment, the moment is on longitudinal axis. Okay, so bending moment is transverse or lateral axis. Okay, it will happen on this axis, and in twisting moment it is longitudinal axis, right? Okay, so these are the internal forces. And next thing, structures. Okay, so what type of structure we are dealing with? There are 2 parts. broadly classified as two parts. One part is rigid jointed structure, and number two is pin jointed structure. Okay. In case of rigid jointed structure, example is take as frame. Okay, any portal frame like structure, and pin jointed structure is like truss is. Okay, so frame is like this. Take this as fixed support. This is a hinge. This is a rigid jointed structure. Okay, all the joints are rigid. That's why this is a rigid jointed structure. And truss is look like this is a hinge support. This is a truss structure. Okay, these joints are pin jointed. Okay, so this is called as pin jointed structure. This joint is pinned, right? Remember one thing, in case of truss, only in case of truss, all members carries only axial forces. Only axial forces. In case of truss, all members carries axial forces. Okay. So these two type of structures we have to deal with, and let us know what is equilibrium equation, right? We have to know what is equilibrium equation. Okay. Equilibrium equation. We have three equilibrium equation. Summation of H equal to 0, summation of V equal to 0, and summation of M equal to 0. That means summation of horizontal forces is equal to 0, summation of vertical forces equal to 0, and summation of bending moment is equal to 0. Okay, these three are the equilibrium equation we have to use. Now, a very important thing is coming around. The concept of global loading and vertical loading. Okay, the concept of global loading and vertical loading. Acha. Remember one thing, in case of beam there is 2 points. Okay, in case of beam, if loading is vertical and the supports are at the same level, then no horizontal reaction will develop. In case of beam, if loading is vertical and the supports are at the same level, then no horizontal reaction will develop. Now take this example. Okay, this is I am taking a simply supported beam. This is a simply supported beam, this is the hinge support, and this is roller support. Take a load as P inclined on the beam, so this reaction will come. Now take this point A and take this point B. So in this direction, restraining force is Ry, this is Rx, and this is also Ry. Okay, so here two support reaction, and in this support one support reaction. So total number of support reaction as Re is equal to 3. Clear? And we have equilibrium equation number 3. Okay, now this is one example. Okay, but if the load comes vertical, not inclined, clear? This is A point, this is B point, this is Ry, this is Rx, and this is Ry also. So you will write, sir, Re is equal to 3 and E equal to 3, but this is wrong, as the force comes as vertical, it has no component in horizontal direction, so there will be no Rx also. Okay, so in this case our Re will be 2 and our equilibrium equation will also be 2, as this is only summation of Fy equal to 0 and summation of My equal to 0, as there is no horizontal forces, right? So in this case our support reaction is 3, number of support reaction is 3, and equilibrium equation is support reaction is 2 and equilibrium equation is 2 also. So you can see the differences between if we allow inclined force and if we allow vertical forces. That's why this assumption comes in case of beam. If loading is vertical and the supports are at the same level, here the support are the same level, right? Then no horizontal reaction will develop. No horizontal reaction will be developed, right? And the other part is in case of beam, if the loading is vertical but supports are not at the same level, the horizontal reaction will be considered. Okay, if vertical loading is done but these supports are not at the same level, something is up and something is down, something is down and something is up, then the horizontal reaction should be considered. Okay, come, please put this in your mind. Now, what are the types of structure? Types of structure. Okay, we have two types of structures. Number one is determinant structure, and number two is indeterminate structure. Okay, now what is indeterminate structure and what is determinate structure? We have to know the basic differences between determinate structure and indeterminate structure. What determinate structure have the properties and what indeterminate structure have the properties, we all have to know. Okay, so first comes determinate structure. If all the support reaction and no forces can be found, okay, so determinant structure, what can be called determinate structure? If all the support reaction and no forces can be found out using equilibrium condition. Okay, and what is indeterminate structure? If all the support reaction cannot be found out using equilibrium condition, equilibrium equation or condition, then the structure will be called as indeterminate structure. So this is the difference between determinate structure and indeterminate structure. Okay, so here are some properties of determinate structure and indeterminate structure. What are the properties? Properties are in case of determinate structure, to analyze the material properties and cross-sectional properties are not required in case of determinate structure. But in case of indeterminate structure, to analyze we need additional equation, okay, such as known as compatibility equation. You all know in future what is compatibility equation in the form of slope and deflection. Okay, and the other point is thermal stresses due to temperature change are not developed in case of determinate structure. Okay, but in case of indeterminate structure, stresses will be developed due to temperature change or settlement. Take a note at this. The properties. Okay, what is the properties? Number one is in case of determinate structure, to analyze material properties what are the material properties? We all know that Young modulus, shear modulus, bulk modulus, these are the material properties. Okay, so to analyze material properties like Young modulus, shear modulus, or modulus of rigidity, you can say, bulk modulus, etc., and cross section properties. What is cross section properties? Cross section properties like what is the area of cross section? Okay, what are the moment of inertia? These are the cross section properties. These properties are not required in case of determinate structure to analyze the material. Okay, but in case of indeterminate structure, to analyze we need additional equation. Additional equation that is known as compatibility equation. Compatibility equation in the form of slope and deflection. What is slope and deflection? We will come later. Slope and deflection equation. Okay. So these are the properties. Okay. Now, what is indeterminacy? Previously, I have told that indeterminacy is two parts, static and kinematic. Okay. So what is static indeterminacy and what is kinematic indeterminacy? Let's gist it out. So there is two part, static and kinematic, right? So in static we denote this as ds and kinematic dk, d suffix k. Okay. Achha. So what is static? Based on external support reaction and their internal member forces or geometry. But kinematic, this is based on degree of freedom only. Okay. What is degree of freedom? I will tell later in the next chapter. Based on degree of freedom that is available at all joints. Okay. Now this static indeterminacy have two parts. Okay, that is external and number two is internal. Okay. So from the next class I will elaborate about this, what is external static indeterminacy and what is internal. So take a brief of these notes. First we say what is indeterminacy. Indeterminacy comes into two parts, static and kinematic, and external support reaction is fixed support, hinge support, roller support. This is your number of support reaction comes. Then equilibrium condition you can know about, right? Next, what is the internal forces are there acting on a structure, what types of structure we are dealing with. There are two types of structure. This is rigid jointed structure and pin jointed structure. The example are frames and trusses. Okay. That's all for today now. See you in the next class. Thank you.